Hey, how's it going, guys? So here we are back again on the HVAC Optimal Start Math Playground. So we're studying mechanical engineering theory for the mathematical models on how to optimally start the HVAC systems before the building is occupied. Based off of some PNNL research, read the paper. Other videos we've looked at the paper, so reference those. We're on the bonus material. This bonus material is just to do the little bit of the theory on some of the math running in the background of these math models. So we're on day 2 of the bonus days for matrices. So let's get into it. Okay, so day 2, matrices and transpose. The goal is to learn how matrices are represented and why transpose exists. A matrix is simply a list of vectors. So here's our list, and Python is kind of similar to an array. I don't think that true Python has a real array, so this is kind of mimics an array called a list. These little brackets here, and this was our model 2, I think. So it just looks like we have some fake data. The transpose flips rows into columns and is written as XT, X transpose. Transpose is required to compute X transpose times X, I think. X transpose times Y. These terms appear in every least squares regression. So here's a mini example, like I think we had yesterday. Let's just copy this to here. This was our lesson from yesterday. So if I just do Python math lesson. Okay, so this is, what is it doing here? So it looks like this is our original list of arrays in this format, just like 2 by 2. And then it's actually rewritten the array transpose, so these are all in its own list as well. So 2, 4, and 6 are now in its own list, and 1, 5, and 3. So this is kind of a neat little script that XT it's defined as an empty list, and then it for loops through the length of this right here. So that would be, I think this value would be 3. I'm just going to print so we can see what that looks like. Let's see what happened here. And then maybe we can print both of these next to each other. Just see what these look like. X. So it's 2 and 3. I just have to think about this a little bit. We could actually move this up here. Whoops. Okay, so this is 2 loops going on here at the same time. So this is one for loop, and then this is another for loop inside of the for loop. So this for loop I iterates 2 times through here through our print, and then this iterates 3 times. So it's kind of a cool way that it's kind of like a computer science-ish way of transposing the data. So the length of this, so it's just saying like this is a value of 2, That's the length of the first indice. This would be x1, x0, x2, x1, x2. And then the length of x would be a value of 3. So there's 3 objects inside here. So this is just saying the length of rows, and then this is the length of columns. So value of 2 and 3, then that gives you the value of our for loop iterations. And then how it packages then the data here. So it's saying to yeah, kind of a cool way of doing it. That would take me a little while to figure that out if I had to do that manually. Okay, so transpose a 2x3 matrix by hand, a different one. Okay, so I'm just gonna make one up. So maybe I'll just delete this. I'm just gonna say, just make up some numbers here. Let's do 11. Whoops. What did I do? Let's do accidentally full screened. Full screen, if that's okay. Make this. Let's do 4, 4. Do 5, 5. 6, 6. Okay, so if I was going to transpose this manually by hand, this new array would be, it would look like this. It would look like 11, 22, 33, and this would be 44, oops, 55, 66. All right, I think we got that exercise done. Verify the new dimensions. Okay, so that's same thing I just deleted. So that would be print the length operator in Python. So that would be XT. This should print 2. So that's printing like our columns right here. And I think if we want to do rows, I would do length XT and another slice operator. Okay, so length. What did I do here? I think I have something screwed up here. There we go. 3 by 2. So I think that makes sense. So rows, columns. So our rows are 3 values, and our matrices and our columns are 2. Okay, so I think we got that part done. Why is X transpose X always square? I'll have to think about that. I don't know. That doesn't make sense to me. I might have to ask AI on that one. Sorry. Let's just go. Short answer, X transpose X always square because it multiplies the matrix with its transpose, which is matching inner dimensions and identical outer dimensions. Start with X shape, that means the number of samples. P is the number of features. I guess that kind of makes sense. So it's just like a shape. You know, it's just the shape of the array will always be square. That's a square matrix, always, no exception. Length times width, you know, is always is always square. Okay, I think we'll leave it at that. So then to write your own transpose routine, this is really cool. There are some fancier computer science-ish ways of doing things where you can put all of the code inside of a list operator. Gosh, I don't even know if I should be able to attempt that. I think it's kind of confusing, but I think what we could probably even try, maybe let's try it, is NumPy, the math computing library in Python. So I think you could do, people usually import NumPy as NP for short. And then we could say XT NumPy equals MP. No, I think it's X. I think we could do NumPy. Actually, I'm not sure how you do this. So x.mp.t, I think. This won't work because the NumPy has a built-in transpose operator in it. It's gonna error out. A list has no attribute. Okay, so I wonder if I just do of course maybe we could just look up Google, so maybe I'll just cheat a little bit and say NumPy transpose T operator. See what we get back. So maybe we need to make it a NumPy array first. And then we can just call it like a dot. Okay, so we just have to call this. I'm gonna copy that. I'm just gonna say X. And then I can say, maybe I'll say this MP array. Print U for learning purposes. Then I think we could just do transpose it with NumPy. So I could say T equals this value with a transpose operator. Then we could just print this guy, see what it looks like. Print might be kind of fun to show this like that. Well, let's see what this looks like. Okay, so this is our original array in NumPy array format, and then yeah, this is it transposed through NumPy. So it yeah, a lot going on in here with the NumPy computing library package. It's pretty powerful, and yeah, I wonder if it would be interesting just to put this NumPy. We could actually just do, probably call it like this. looks like we have two. So this is our manual array, and then our one that we transpose with NumPy. We could maybe even say do these guys equal each other. And in Python, that should return true. True. Cool. Okay. Well, I think this is enough for today. My background, I don't have a lot of experience in learning this stuff, so like maybe some people with like computer science degrees, they probably have lots of experience in whole college semesters and this alone. So for me, I'm actually kind of learning on the fly and filling in some holes. And part of my life journey, I just never studied it too very hard. So I think that is enough for one day, and then tomorrow I think we get into some more matrix multiplication. I guess it could be kind of intriguing maybe to do well, maybe one day at a time. It just tomorrow we'll get into matrix multiplication. So, and once again, this is actually going on under the hood in the Model 3 in the paper. So like the whole point of us studying this is getting into the weeds of Model 3 here defined in the paper. It's multiple linear regression, which has a bit of math going on behind the scenes, and maybe also like we can kind of dive into this a little bit too. I have this running in the field, which I showed on the last video of in the Niagara world. Same math here, but in Java format. Like this is all running behind the scenes in Java. This is all vibe coded. Ton of testing. Like I've been, that's why I took the breaks the last couple of days, but maybe as we progress through these bonus days, like we can kind of start diving through some of these methods in here, where it's this matrix multiplication and algebra, like we're doing it all by hand in Java through here. So yeah, we'll get into this a little bit more. So I know in Python it looked a little bit different, but this is basically the Java format. So, and we had to do this all manually because there is not a NumPy that I have accessible to me in Java world in the program object, is what it is. So it's a good learning experience. So yeah, that's it for today, guys. So see you tomorrow. Have a great day.